So we have now a dataset that contains completely transformed variables that are ready to be used to train machine learning algorithms. Our dataset contains 79 predictor variables, and we discussed earlier that actually reducing the number of variables may help reduce overfitting, but more important, makes the models more interpretable for the users of these models, and even more important for the scope of these clouds is that having fewer features to deploy simplifies the deployment of the model substantially. So in this notebook, we are going to try and reduce the number of predictive features. We're going to import pandas, numpy, and matplotlib for plotting. We want to train a lasso regression to predict the target, and we're going to use the SelectFromModel from scikit-learn to select the features that are important for this lasso regression. Lasso has a characteristic that it applies a penalty to the coefficients of the variables in order to try and reduce the overfitting. And it does it in a way that it can reduce some of those coefficients to 0. So in essence, we're multiplying the variables by 0, which means that those variables are not really adding anything to the prediction. So if that is the case, instead of having them in the lasso regression, we can actually go ahead and remove them. So let's do that. We load first the transformed datasets. You will find these datasets after running the previous notebook in this section. So if you haven't done so, go ahead and do it. We load the transformed target. Remember that this target is logarithm transformed. We also created this in the previous notebook. And now we perform the feature selection step. We use SelectFromModel, and we need to pass the lasso. Here I set up a regularization penalty, and I do this arbitrarily because I want to keep sufficient features to show you as many details as possible in the course. But in order to determine the best penalty, we would have to do cross-validation, or at least go ahead and try different values. So here we're keeping it short to try and profit as much as possible for the course, at the cost that we may not produce the best performing or even the simplest model. And we set the random state for reproducibility. We then fit the selector to the train set, and we have to pass, of course, the target, because this procedure is fitting a lasso to the data. And now the selector has an attribute called getSupport that if we sum is going to be 36. GetSupport is a collection of true and false. So the sum of true is 36, means that 36 variables were selected in the model. We can capture the selected features in this variable, applying the getSupport true-false vector to the columns of the training set. So this will return a list of 36 features, the ones that were selected and that we print here. These are the 36 features that were selected as the most predictive. Here we also print the original shape of the data, that is 81, and here I print in the selector, we store the estimator, which is the lasso, and the lasso has a coefficient attribute which stores the coefficients that it uses to multiply each variable in order to output the prediction, and some of these coefficients were ranked to 0. So we sum the variables that were ranked to 0, and we see that they are 45. So 45 is all the variables that were eliminated from the original 81 variables. We are going to save the list of the selected features in a CSV file, and if you want to learn more about feature selection, there is an online course and there is also an article that you can read online. That is all for this video.